Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Welcome to Lady Khadija radiallahu anha online college. May God be pleased with her. This chapter is the chapter on parametric equations as part of the A-level Year 2 Pure Maths curriculum. Today's question looks at parametric equations involving sine and cos, and we're asked to work out the coordinates of where the curve crosses the axes, in particular in this one, the y-axis. Let's begin. Bismillah ar-Rahman ar-Rahim, in the name of God, the most gracious, the most merciful. The equations are x equals cos t and x equals cos t plus sine t. Y is equal to t minus pi over 6 all squared. So let me just fill that in. T minus pi over 6 all squared. And the question is, can we work out the points, so there's more than one, A and B, where the curve cuts the y-axis? Okay, first thing you want to do is just picture the y-axis, and that's the line going straight up. And you just want to realize that every point on the y-axis, like that one and this one and this one, the x-coordinate is always 0. The x-coordinate is always 0. So that's the main thing we're going to use here. We're going to say if we want to find out where the curve cuts the y-axis, then we know that x is going to be 0. Let's use that in the first equation. So we've got x equals cos t plus sine t. Let's substitute the 0 for the x. So now we've got 0 equals cos t plus sine t. We can rearrange that so we've got sine t on the other side or cos t on the other side. So we'll have minus cos t equals sine t. And then if we divide both sides by cos t, so if I divide both sides by minus cos t, then we can take advantage of sine divided by cos being tan. So that would work out to be tan t on the right, and on the left, minus cos t divided by itself would just be 1. So we have tan t equals 1. Let me just make sure that I've not got the minus sign wrong there. I think I have. I think it should have been the other way. So just go back a couple of steps. So we are going to take the sine t across. So that's minus sine t equals cos t. Now divide both sides by cos. So dividing by cos t on the right and dividing by cos t on the left. So we should end up with sine over cos is tan, so that works out to be minus tan t. And cos t divided by cos t is just 1. So we have minus tan t is equal to 1. Take the minus on the other side, and then you have tan t is equal to minus 1. Inverse tan, and you'll get t is equal to pi over 4. Sorry, minus pi over 4. But that's just the first answer for tan. Remember, to get the following answers, you can add on 180 degrees, which is also pi over 2. So the next angle will be 3 pi over 4. Sorry, you add on 180 degrees. Let me just write that in the corner. So 180 degrees. You can add or subtract 180 degrees to the first angle to get the next angle and the next angle and the next angle. 180 degrees is pi if you're working in radians. So adding pi onto this would get 3 pi over 4. How many of these you need depends on the question. So normally in the question right at the beginning, they tell you that there's a range for the angle. And in this question, the range was t is in between minus pi over 2 and on the other side it's 4 pi over 3. So that means these two answers here are enough because they fall in between that range. Minus pi over 4 is just on the left hand side, and 3 pi over 4 is just a little bit to the left of 4 pi over 3. So those two answers are great. We've got the answer for t. What we want are the coordinates. So we've got the x coordinate already, x is 0. Let's get the y coordinate now. So we're going to take the equation for the y coordinate, and we're going to substitute in the t values. We can't do both at the same time, so we're just going to have to do one at a time. So let's go with t equals minus pi over 4 first, and then just type it into your calculator to figure out what y is equal to. You're using minus pi over 4 for your t value, take away pi over 6 and all squared. So that should work out to be, I'll give you a second to work it out on your calculator. Okay, that works out to be 25 pi squared over 144. Next, you take the next t value. So the next t value is 3 pi over 4. Do exactly the same thing. Just substitute it into the y equation. Let your calculator do the hard work. Just type it in, 3 pi over 4, take away pi over 6, in brackets, all squared. And if you do that, you should get 49 pi squared over 144. Okay, and that means we have the coordinates of the 2 points we need. So A and B, we can say the first one A, the second one B. The first one A has an x coordinate of 0, because we know it's cutting the y-axis, and at the y-axis x is 0, and the y-coordinate we'll grab from here. It's 25 pi squared over 144. That's the first coordinate, pair of coordinates, and the second one for B, again, x is 0, and the y-coordinate we've worked out just here. And that is your second coordinate. So hopefully that's all understandable. Let's just quickly do a quick replay to make sure that you understand the basics. So we started with two parametric equations. We're trying to figure out where does the curve cross the y-axis. So crossing the y-axis, the first thing you have to realize is the x-coordinate is always 0 on the y-axis. Take the parametric equation for x, substitute in the 0, rearrange, you'll then get an equation for t. You can inverse tan to get what t is. Remember to try and get more than one answer if it's a sine, cos, or tan type equation. And then substitute those t values into the y equation one at a time. Here's the first one going in, then the second one goes in, and that's your coordinates of your 2 points. First point, 0, 25 pi squared over 144. Second point is 0, 49 pi squared over 144. Join me for more on parametric equations. Assalamu alaikum wa rahmatullahi wa barakatuh. Peace be with you and the mercy and blessings of God.